Hi everybody, welcome back to another My Tutor online school tutorial at GCSE Maths. Today we'll be covering the sine and cosine rule, so a bit of trigonometry. As always, this session is 1 hour in length, so it will finish at 3 p.m. And it will comprise of me kind of doing some talking at you with some questions. I've even got a quiz today, so very exciting stuff. So this session is led by me, Molly. I'm a computer science and math student at the University of Bath, just finishing my second year. And I've done over 200 lessons now with my tutor. So hopefully that means I know what I'm doing. So throughout the lesson, please do make great use of the Q&A and the chat functions. So just pop messages on there telling me to re-explain something, slow down, speed up, asking for another example, and also share your answers in there because I actively encourage you to try to get the answer before I've finished explaining it, and we can have a look on there and see how people are doing. So oh my gosh, I've already got a joke through for the end. I love this. Okay, so let's jump straight into it. So the sine and cosine rule are both kind of just formulas that we use in trigonometry that we use for working out either sides or angles of a triangle. Now this applies to any triangle, so not just right-angled. So with Pythagoras and SOHCAHTOA, which I think we're going over tomorrow, that only applies to right-angled triangles, whereas the sine and cosine rule applies to anything. You can use any triangle, doesn't matter if it's not right-angled. So what I'll do is I'll start off by explaining what both of them are for you. Yeah, and we'll see what they're like. So let's start off by looking at the sine rule. So sine rule. Now they're called these because the sine rule uses the sine trig function and the cosine rule uses the cosine trig function. So there are three: sine, cosine, and tangent. And just to kind of, as an introduction, and I'll say this tomorrow as well, trig functions are literally just kind of things that map something to another. So I feel like they're often kind of thrown around and just say, oh, just do sine of 54 or whatever. And it often doesn't kind of make any sense. So what they do is, if we take, for example, sine, it's basically just a graph that looks like this. And this carries on. This is from 0 to 360 and it carries on and it does a loop. And when you put in sine of 54 into your calculator, so it goes up to 1 here and down to -1. You'll probably have seen this before. And this is 360 degrees. This middle one's 180 and so on. So when you put in, say, sine of 54, all your calculator does is it kind of has this graph and all of these values, and it finds 54 and it sees where it is and it gives you whatever number this happens to be here. So that's all it is. Someone said, do we need a calculator today? Yes, if you want to kind of play along and answer the questions as I'm going through them, I'd recommend grabbing a calculator if you can. Phone calculators will do. I think if you turn them on their side, you get more functions, and there will be sine and cos on there. So hopefully this makes sense. This is just a very brief kind of what on earth are the trig functions. It's just all your calculator's doing is finding the value and spitting out whatever it is that it matches to on the graph. Don't worry if you don't follow that, but I think it's better to have some sort of understanding than just be told, oh yeah, they're just things that you do. So anyway, I'll stop dilly-dallying and we'll talk about what the sine rule is. So for both of these, we label them in the same way, our triangles. So we label our sides, make that a bit smaller, A, B, and C. And then we label the corresponding angles with the capital letter. And what that means is the angle that's opposite it. So for example, with A, it's this one here, with C, it's this one, and with B, it's this one. So it's like the angle that they don't make up at all. So for A, it's this angle made up of B and C. This is what we call A. So this is A, capital A, this is capital B, this is capital C. And this is kind of our generic kind of notation for labeling triangles. This is what we do for the cosine rule as well. And also I think later in the week we're going over, yeah, we are, areas of triangles. And again, this is how we label it. So yeah, this is really important to understand what this means. And then what the sine rule says is this. It says that A over sine A equals B over sine B equals C over sine C. So what that means is you'll only ever really use like 2 of these together, but basically what it means is that for every single side, the side over the sine of its angle is the same. So the ratio of the sides and the sines of the angles is the same, which I think is really cool and kind of a weird, well, it seems weird, that relationship between them. And also this will make a lot more sense once we do some numbers with some actual examples. The other thing that this means is because you can, when you're rearranging equations, you can flip fractions. We can write this the other way. So we can write this as sine A over A equals sine B over B equals sine C. That was an awful C, sine C over C. The reason that we might want to do this is because you'll see once we do some examples with some numbers, but it's a lot easier to have what you're trying to find on the top of the fraction. It just kind of makes the manipulation of it easier. So if we're looking for a side, we'll use this one. If we're looking for an angle, we'll use this one. It just makes the algebra and the manipulation that we have to do a lot easier. So yeah, we'll do some examples of it, and hopefully, as I said, it will make a little bit more sense. So I've got some worksheets from this. Again, I'm using Maths Made Easy, my favorite website to find worksheets. And I haven't opened them because I wanted to show you that they've got loads and loads of things. So they've got 2 worksheets for each rule and then 1 combined. So it's super useful. Plus they have worked through questions and stuff. I feel like I'm being sponsored by them. I'm not, I wish I was. So let's have a look at this sine rule worksheet here. And just jump in with a question. So let's do this one first of all. So we've got to find the side marked X. So here we've got a triangle. And what I'm going to do once I've shown you both of the rules as well, I've got a really nice little flowchart that I kind of use to decide whether you need to, which rule you need to use. So I'll show that at the end of today and at the end of tomorrow because I think it's super useful. So this is, we've got, basically to know that you need to do the cosine rule if we've got a side and an angle opposite it. So we've got this and this, and this and this. You can kind of like see those 2 pairs of side angles. So what we do is, you can label them if you want to. I'm not going to label them with any A's or B's. I'm just going to kind of circle what the pairs are. So we've got this. So because we're looking for a side, I'm going to use that one. So X over sine 47 is equal to this and this are a pair. So 8 over sine 65. So hopefully that makes sense where I got that from. Hopefully this color coding works, that you can see that this is a side angle pair and this is a side angle pair. And that's what we're going to use for that. So now all that remains is to find X. Now, I much prefer and would really, really advise you to just try to put one thing in your calculator. Because sine of, basically nothing is going to give you a whole number unless it's, I think, sine 30. So if you do this first, you're going to have to round it and then you can get rounding errors and stuff. So basically, I would really recommend just trying to rearrange it first and then just put one thing in your calculator. So what we're going to do here is multiply it up by sine 47. So we take x, and when we multiply up, remember we just multiply the numerator. So we just multiply that number on the top. So x equals, and we're going to write this as 8 sine 47 over sine 65. So hopefully that makes sense as to how I kind of did that. Someone said, can you explain where the 47 and 65 came from? They're these angles that we have on the triangle. And the reason that they went this way round was because the sine 47, so the 47 is opposite the x, and the 65 is opposite the 8. So that's why they're that way round. Someone said to slow down. Someone also said to speed up. So I'll do the next example a bit slower and hopefully cater for everybody's needs. So then we can just pop this into our calculator here. Unfortunately, I don't know if I'll be able to put it all into one calculator. Maybe I'll have a look here. So after just saying try to put it all in at once, I'm not going to be able to, but I'll try. So 8 sine 47. So 8 sine 47. Oh gosh, it's like watching an ape use a computer, isn't it? Right, 8 sine 47. All of that. Okay, I'll put it in brackets. 8 sine 47 divided by sine 65. And there you go. Hopefully that's what you guys got as well. 1.19 or 1.2. Someone said you seem to be struggling. Yeah, you can't tell I do a computer science degree, can you, when I can't make a calculator work? So hopefully this makes sense here. So we get 1.20 if we round it to 2 decimal places. Oh, I just realized this will be in radians. It won't be that. I apologize. 6.45 or 6.46. Sorry, that's important. Radians are a different measure of angles, so it will be 6.45. Someone said, will this come up on a non-calculated paper? No, basically. Yeah, so 6.45 or 6.46 if we're doing rounding. So x equals 6.46 meters. Important that you put the same unit that the other side length is in. So don't worry, I'll be doing another couple of examples. Oh, 6.56, did I write it wrong? A couple of people said 6.56. Okay, that's fine. Well, we'll go with it. Right, let's do another one. Let's have a look at, let's do this one here. So hopefully you can see that okay. So again, we can see that it's the sine rule because we've got these two kind of side angle pairs. So we're going to look at what they are. So we've got x and 19, and we've got 11 and 31. Now we're looking for an angle, so we're going to put the sine angle on top, because hopefully you can see from that last one why it being on the top is easier, because then you just multiply it by whatever's on the bottom. So we'll say sine x over 19. So remember, it's always sine of the angle and the corresponding side. So that's equal to sine 31 divided by 11. So hopefully you can see where I got those from. I'm just matching up the sides. And then we want to find sine x. So we're going to multiply it by 19. So sine x is equal to 19 sine 31 over 11. So again, that's just like before. I've just multiplied up by that 19 on the top. Someone said, how do you tell it's sine as opposed to tan or cos? That's a great question. That's just because this is the sine rule. This only works with sine, so it's always going to be that for this rule. So then we can either just straight away put in inverse sine of all of this, or I'll break my own rule and do it in pieces just to show you. So we'll work out this. So sine x equals, so 19 sine 31 divided by 11. So 19 sine 31 divided by 11. So 0.8896. So let's keep it to a lot of decimal places. So that's what sine of x is. And then to work out x, we have to inverse sine it. So let me know if that doesn't make sense. This basically just does the reverse of what sine does. Oh, okay, a couple of questions. Someone said in an exam, did they tell you it's the sine rule? No. But hopefully once we've covered both the sine and cosine rule, we'll be able to, like, I'll show you examples of how you can tell which is which. And someone said, can you explain how to use sine inverse? Sure. So if we remember this, and I told you that when you put in, say, sine of 54 onto a calculator, it finds 54 here and gives you this value. Now what we're doing is the opposite, and we're giving it a value from here, and it's just telling us the first value that it comes across that's correct. So it's literally just doing the opposite. You give it a result, and it tells you what the angle must have been to give you that result. And to get it on your calculator, it will be either like shift sine or something along those lines. So I always just have to Google these. Can we do? Oh my God, you can do it on here. Sorry. Again, it's like watching an 8 learn how to use a computer. So 0.8896. And if you see it as arc sine, that's the same thing. Sine to the -1, inverse sine, arc sine. These all just mean the same thing. So here we see 62.82. So let's just do it to 3 significant figures. So 62.8 degrees. And there's the solution. Hopefully that makes sense. Someone's asked how to convert into radians. I'm not 100% sure on all of the calculators. Normally there's something on the settings where you switch between the degrees, but you'll have to, there's a load of manuals on Google. Okay, someone's, oh gosh, a lot of people are telling me to speed up and a couple of people have told me to slow down. So I'll do the next one slower and then go back to this pace, and hopefully that will be okay. Someone said, is there a rhyme or something you use to remember these rules? Unfortunately not. I think you get them in the formula book for most exams. But you do also use them enough that you'll probably kind of remember them anyway, hopefully. I wish there was a rhyme. So let's have a go at another one, and I'll do this one a bit slower. So let's have a go at this one here. So again, we'll go over at the end how I can tell that this is a sine rule. But for now, we'll just know that it's a sine rule because I said so, right? So the first thing that we're going to do is match up the angle and the side pairs. So the way that we do that is, so let's first of all look at this angle 31. The side that it matches with is the side that it's not connected to. So we can see that this angle 31 is connected to this side and this side. So therefore, the side that it matches up with is this one, the 12. Then we'll do the same for the other pair that we have. So this x angle. And again, we see that it's connected here and here. So the side that it's not connected to is this one here. So this 7. So that's how we kind of match it up into pairs, because for the sine rule, that's really what we need. We need it to be in this kind of pair format with our A and our A, our B and our B, our C and our C, whichever we use. So then what we do is we choose whether we want the angle on top or the side on top. That's just choosing between whether we're going to write it like this or we're going to write it like this. They're identical. It doesn't matter at all. We're just going to choose the one that's easier for us. So because the x that we're looking for is an angle, we're going to choose the one where the angles are on top. So the sine of the angles. So we'll start with our green one. So sine x. So it's always just, in these kind of side angle pairs, you just do sine of the angle over the side, and you just equate those. So sine x over 7, hopefully you can see that those are the green pairs there. And then for the blue pairs, that's sine of 31 over 12. Hopefully that makes sense. Oh my gosh, now people are telling me to speed up. This is so stressful. So now we're gonna try to get sine x by itself so that we can solve it. So what we're going to do is we're going to multiply up by the 7. So we do sine x. And remember, when we multiply it by something, we just multiply the numerator. So we're going to write this as 7 sine 31. So let's first of all work out what that is. So 7 sine 31 divided by 12. So 7 sine 31 divided by 12. 0.3004. 0.3004. And then remember, if sine x is equal to this, to get x, we inverse sine it. It's just how like multiplication and division are opposites, addition and subtraction are opposites, sine and inverse sine are opposites. So to kind of unsine this, we inverse sine it. So we do the inverse sine of 0.3304. And we get 17.48 or 17.5 if we're rounding it, and that's in degrees. So I tried to go nice and slow for that, and I guess it worked because people told me to speed up. So hopefully everyone's kind of following this now. So I'm just going to do one more example, and then we'll move on to the cosine rule. So the one more example that I want to do is one like this one. I think. Oh yeah, that doesn't actually have one. So let's do this one here. Oh. So the reason for this is because there's like a tiny little extra step before we actually get into the sine rule. Someone said, what did you do to get the 17.5? I did inverse sine of 0.3004. So with this one, we can see that we've got this kind of pair here, this x 81 pair. So we can mark that. What do you think we have to do? Because obviously we've got this but no side over here, and this but no angle over here. So what do you think we can do to find one of those? Just put on the chat or the Q&A if you have any ideas. Yeah, someone's got it. Someone suggested all the sides are 32 because it's an equilateral triangle. If they told you it's an equilateral triangle, you could do that. But also then all the angles would be 60. So unfortunately, you can't do that. But it's definitely a good thought. Yeah, a couple of people have got it. So all of the angles in a triangle add up to 180 degrees. So we can find what this angle is here. So we see that 81 plus 42 is 123. And then take that away from 180 to find out what that final missing angle will be. And that's 57 degrees. So hopefully that makes sense. So then we can see that this is 57. And then we've got this side angle pair here. So it's just that we weren't given, yeah, a couple more people got that. So all it is that we weren't given that angle to start with. So they were a bit tricky with it, but we can see here that that was something easy we could do. And I would encourage anyway, if you start a question and you've got two angles but not the third, find what the third is, because the chances are you're going to need it or it will come in helpful somewhere in the question. So it's often a good thing to do. So, okay, now we can do this question as usual. So we see that we've got, we want this time the angles on the top because we're looking for x. So x over sine 81 is equal to these blue ones, so 32 over sine 57. So x is equal to, remember we just multiply the numerator, 32 sine 81 over sine 57. So let's work that one out. So 32 sine 81 over sine 57 gives us 37.69 or 37.7 if we're doing it to 3 significant figures. If they don't tell you, that's probably a good kind of guess to go for. 37.7. Already forgot what I said. 37 point, oh, sorry, not degrees. This time it's a side, so it's meters. Because this 32 is in meters, so it's going to be the same. So hopefully that makes sense. Yeah, okay, yeah. So a couple of people asked, how do you know which one goes on top? Why have I put it the other way? Either would work. The reason is you put whatever x is going to be in on top. And that's just so that you can always multiply up by this bit. So here we were finding a side length, so we just put the sides on top. Whereas in this one, we were finding an angle, so we put the sine x on top. Because if you put it on the bottom, it's going to be really difficult to get it out onto the top so that you can solve for x. So it's, yeah, a lot easier. Someone said, why is it 32 sine 81? Because we've multiplied by sine 81. You always put the number first, just like you'd always put like 3x instead of x3. You always just put it that way round. Okay, so if you've got any more questions, I'll come back to them at the end in the kind of Q&A bit, the questions that I take in the last 10, 15 minutes. But for now, I want to cover the cosine rule to make sure that we've done both. So the cosine rule, it's a bit trickier just because it's a bit trickier to remember. It's less kind of this over this, this over this. So we start in the same way. We label our triangle with our 3 sides, A, B, C, doesn't matter which is which, and then the angles with the capitals. That's the important bit. And then what this tells us, the cosine rule, or the cos rule, as I'll probably call it once I get lazy, tells us that a squared equals b squared plus c squared minus 2bc cos a. Excuse me. So that's a horrible looking thing, right? I mean, I think it looks horrible and I like maths. So, but it's really not too bad. Key thing to note is that we don't actually need to know that these are C and B. So this is all that we're using. And what it says is that, so this squared is equal to this squared plus this squared minus 2 lots of this, cos this. It will make more sense once we put some numbers in it. And again, this should be given in your formula booklet. And also, bear in mind that I haven't actually had to use this for a few years and it's ingrained on my memory. So I promise you will automatically learn these because you'll use them enough. So let's jump in and have a look at an example. So let me bring up a cosine rule worksheet from here. And we'll have a look at one of these. So let's just have a look at the first one here. So here we go. So again, I'll go over at the end how we can tell which one it is that we need to use. And you will get used to it, you will pick it up. So here it's the cosine rule. So we've kind of got our small a and big A, and we've got our B and our C. It does not matter at all which way around B and C go. We can choose them to be anything. So for this one, what I'll do is I'll label it all and write out the cosine rule. So I'll just call this one B and this one C. Doesn't matter. And then remember that the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. And then we're literally just going to plug in these values that we have here into this rule. So a squared, so x squared. In fact, let me do this in a different color. So x squared equals b squared plus c squared minus 2 times b times c times cos A. So hopefully that makes sense where I've got those numbers from. It's all just about recognizing, I guess, which one's A, because it's going to be the one that's like opposite the angle in question. So now we start to work out these parts. Oh yeah, someone said, can we have a go first before I go through it? Sure. So what I'll do is I'll just give it a minute. Someone's again said, can you slow down? I'll do another example after this one. I'm a lot slower for you. I'll give you guys a minute to try to work this one out yourself and pop your answer in, and then I'll go through it, the best way to tackle it. Just while you're working it out, someone's asked, what level is this? That's a good question. I think on this worksheet thing, yeah, level 6 to 7. And that makes sense. Yeah, they're fairly high grade ones, because they can be quite difficult. But I think you can all tackle them, hopefully. Just while people are working it out, because a couple are coming in, I'll just stop sharing so that I can check the answer without you guys seeing it. And then we'll have a look and go through it ourselves. So mark scheme. Okay, cool. So yeah, just do it to 2 decimal places. Yeah, sorry, people have said that they can't see it. That's just because I was checking the answer. There you go. Okay. So one person's got it right. Okay, I think I'll go through it now, just so that I can. Yeah. 2 people. Okay, cool. So I'll start to go through and explain. So the way that I like to do this is in stages. So first of all, I work out this bit and then this bit, and that already makes it so much easier. So we do. Okay, a couple of people, if people got 300 and something, because a couple of people did, square root it, remember, because that's what x squared is. So the first thing that I do is I add 17 squared and 15 squared. So let's do that. So 17 squared plus 15 squared equals 514. So we have x squared equals 514. And then I do 2 times 17 times 15. So 2 times 17 times 15 is 510. So minus 510 cos 76. And already I think that this is looking very manageable. Now we've got rid of loads of the big numbers. So I would just put in all of this into my calculator in one go. So 514 minus 510 cos 76. And that gives us, I feel like it shouldn't give us that. Oh, why did it do cos sine 76? Sorry, 514 minus 510 cos. Oh, it's because when I press C, it automatically comes up with it. Cos 76. There you go, 390.649. And then we square root that. So that's the key step that a couple of people miss, because that's what x squared is. So then we just square root it. Am I going to get 19.76? So even though this looks like there's a load more working out to do, it's not too much more. And this will always be on a calculator paper. So yeah, hopefully you should be all right, unless you make a silly mistake like me and do cosine. Yeah, a couple more people got it then, which is fantastic. Well done. So let's have a go at another one. I'll do one more. I won't give you, I won't pause to get you guys to do it, but see if you want to kind of challenge yourself, see if you can send me the answer before I finished explaining it. So again, I tend to do this without labeling them because I think sometimes seeing too many labels can be confusing. So we've just got to remember that this is the thing that's like squared, the one opposite the angle. So here we get x squared equals 10 squared plus 6 squared minus 2 times 10 times 6 times cos 55. So hopefully you can see where I got that from. So it's just a squared is b squared plus c squared minus 2bc cos a. So just refer back to that or Google the cos rule if you're lost there. Then I do 10 squared plus 6 squared, so that's going to give me 136. And then I do 2 times 10 times 6, and that's going to give me 120. So now again, this step makes it look a lot more manageable. So x squared equals 136 minus 120 cos 55. And then I'm going to put that all into my calculator. So 136 minus 120 cos 55. That's 67.17. And then I square root that, and that will give me x. So 8.20 to two decimal places. So x equals 8.20 meters. See, yeah, quite a few people got that before I did actually. 1, 2, 3, 4, 5 or 6 people got that before me. So well done. Oh, in fact, more because there was someone Q&A. Fantastic. Well done, everyone. So now let's have a look at one before we do the quiz, which I don't know if it will work. We'll have fun with that. But we're going to do one with the cos rule where it's an angle. And I think this is the hardest kind of case that you'll get. So for example, this. You see how it's the same as before. We've got the same things. We've got like a side opposite an angle. But this isn't our x. Our x is actually the angle itself. Now, I know that some teachers teach like a rearranged formula. I do not like doing that because the cos formula, the cos rule, is in your formula booklet. So you know, even if you know it, you can double check it in an exam. Whereas if you're trying to memorize a rearranged formula, you could recall that incorrectly. I think definitely the best bet, and I would really, really advise you to do this, is to just use the normal cos formula and write it all out, and then rearrange once you've got the numbers. And I'll show you how to do that now, and it's really not too difficult. But yeah, I'd really recommend that over trying to remember a different formula. So what we do is, for this one, I will label them again. So we see that this one's A and this is capital A, and these are just B and C, however we want them. And it's exactly the same. We're just going to write it out using what we have. So this time 16 squared, because that's A squared, equals b squared plus c squared minus 2bc cos a, and a here is x. So you see this is set out exactly the same as before, but instead of this being our x is over here. But we're going to do the same thing. So we're going to start off by simplifying the 16 squared. Basically, first of all, we do any of the just kind of straight arithmetic that we have to do. So 256. And then we simplify 11 squared plus 19 squared. So 11 squared plus 19 squared, 482. Then I do 2 times 11 times 19. So that gives us 418. Cos x. And see again how this is nicer. We've got rid of all of that horrible looking arithmetic parts. Then what I would do is I would add 418 cos x to both sides. This just means that we've got our cos x that we're dealing with on the left, and that often leads to a lot less confusion. So we're just going to get 418 cos x plus 256 equals 482. Then subtract 256, so 418 cos x equals, so put that there, 482 minus 256, so 226. And then I don't even personally, so that we can just put one thing in our calculator with no decimal points, I just would write this as 226 over 418. So I'm just dividing by 418. So cos x is 226 divided by 418. So then we just do inverse cos of this. So we do inverse cos of 226 minus 418. Oh, sorry, divided by 418. And that's going to give us 57.27. So x equals 57.27 degrees. Hopefully that makes sense. Yeah, a couple of people got it. So hopefully this makes some sense. So just let me know now. Would you like me to do the quiz now? So the quiz is quite short. It's just a couple to have a go at yourself and stuff. So would you like me to do the quiz now or one more example of this, finding the angle? Quiz, okay. The first 3 people said quiz. Oh, a couple of people said one more. Okay, I'll do the quiz and then I'll do one more example because I think most people want the quiz now. So just in case anyone has to go early or something, I'll do the quiz because that's the consensus. Right, so this is the first time I'm trying this and I don't know how well it will work. But I've got this link here. It's called quiz. So I'm going to send this to all panelists and attendees. So on the chat, I've just sent a link. So if you click on that link, you should get to this page that says join a game. And then if you just give it a minute, there's only 4 questions. We're going to click on play quiz. Oh gosh, I'm going to turn off memes. It gives you a meme at the end of each question. Feel free to keep that and turn off power-ups as well because it can just take some time. I'll also take off the timer. So what I'm going to do is I'll keep it up on my screen and you can play along at your own pace if you get them right. But yeah, so it's for you guys to play along. So are people kind of on that link? Because I obviously can't see everyone who's here. Oh, have people done quizzes before? Someone says that they've used it before, so that's good. Okay, cool. So is everybody on it? Has it worked okay? I hope so. No one's saying anything. Okay, fingers crossed anyway. We'll okay, so feel free to just, so I'm going to click play quiz. So this is what it looks like. So just in case anybody can't access it, here's what it looks like. So here's the first question, is what is the cosine rule? So have a look at that, click the one that you think. I'll give it a little bit of time. And then I'll just tell you the right answer. So it's this one. A squared equals b squared plus c squared minus 2bc cos a. Okay. And then, okay, cool. People are on it. So then the sine rule. So the sine rule, remember we can do it in a couple of different ways. But the way up for this, someone said, what's the code? I think if you just click that link that I sent in the chat, it will take you to it. So the correct one here is this one. A over sine A, B over sine B, C over sine C. And then this one here. So yeah, here's one for you to have a go at. So have a go at this yourself, and we want to find x to 1 decimal place. So yeah, this is one where I haven't actually like told you which rule that you're using. And what I'll do is I'll give it a minute for people to do it. Maybe if you just message in the chat once you've done the quiz, and I'll go through this question. It's kind of hard because I can't like tell, yeah, when people have done it. So okay, so do people want me to go through this one now? I may as well. If you're working it out, you can just, I don't know, mute me or something. It's kind of, as like I said, this quiz thing is new to me, so yeah, let me know. So this one is a cosine rule. We can kind of tell because we've got the things that we're familiar with, so our kind of 3 sides in this angle. So we're just going to pop it into the cosine rule. So x squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times cos 44. And then work out these individual bits. So x squared equals, so 5 squared plus 7 squared, that's 25 plus 49. Is that right? 74, do I mean? Oops. (74) minus 2 times 5 times 7 cos 44. So we'll put that in. 74 minus 70 cos 44 minus 70 cos 44, and then square root that to get our answer. So 4.86 blah blah blah. So to 1 decimal place, it's 4.9. I hope, because I made this quiz, so fingers crossed. It'd be quite bad if I got the answer to my own quiz wrong. Submit. Cool, so that one's 4.9. So hopefully people can see this. And then finally, here we want to find x to 3 significant figures. So hopefully you can see how this one is a sine rule question, because we've got this side and angle thing happening here. So I'll go through it because I think enough people have answered it. So, oh, a couple of people have said that they haven't done this one. Okay, I'll wait a bit longer on this one then. I'll give you 1 minute to kind of finish up this one, and then I'll go through it for you. Okay, I'll start to go through it. If you haven't done it yet, just maybe mute me and then unmute me once you've done it and see if it was the right one. Oh, I already copied it. So this is the sine rule. So we kind of spot our pairs here and here and write them out like that. So x over sine 21 equals 23, over sine 35. So x is going to be equal to 23 sine 21. So I've just multiplied up there over sine 35. So let's just pop that in here. So 23 sine 21 over sine 35. So 14.37. So to 3 significant figures, that's going to be 14.4. Submit that. Correct. Man, I didn't even win my own quiz. How sad. But so hopefully everybody, it looks like a lot of people played that. So yeah, hopefully. Yeah, and feel free as well, this quiz. I don't know where I can really put that link, but I guess you can see it in the chat. Maybe save the link and have a go at this again in your own time if you didn't get a chance to now. So did that work? Just because we're nearly at the end, so I'll just kind of do like a Q&A for the last little bit, go over a couple more. Did people enjoy that? Is that something that you want to do again? Do you want me to do something more like a Kahoot, so we're all playing it live together? Which would you rather do? Like, okay, yeah, people said it's good. Yeah, people said Kahoot. I think that would possibly work better, so I can share on my screen and then everybody can do it themselves and choose. Only thing is it gives you the option of 4, but okay, cool. Lots of people said Kahoot, so I'll definitely do that. I've already got some questions lined up, so I'll just shift them over to a Kahoot. So maybe by tomorrow, if you're planning on coming back, the Kahoot app is a lot easier to use than the website, but whatever you want to do. Yeah, so maybe just have that downloaded or ready for tomorrow. Cool, exciting. Okay. Okay, nice. And then that also means that, you know, everyone can see who came first, so it's an incentive to do well. Okay, so let's. Someone said who won. I'm not sure, but okay. So I think what I'll do is go through one more cosine rule where we're trying to find the angle. Is that what people want, or do you have any other questions? Oh, someone whose name on here is PMB got first rank, so well done. What I'll do is I'll start going through a cosine rule question just so that I don't waste any time, one where we want to find the angle. But please do let me know any other questions that you have about anything that we've covered today in the Q&A or the chat, and I'll answer them before the end as well. Okay, so here we've got one where we want to find the angle. So if it helps, again, we can label what's what. So we always start by labeling the angle as A. So then we know which one's little a. And then the others, it really doesn't matter which one's B and C. Then we'll recall what our cosine rule is. So A squared equals B squared plus C squared minus 2 BC cos A. And then we just literally plug these values into here. So our little a is 8 squared. So 8 squared equals b squared plus c squared minus 2 times b times c times cos a. And this time our a is our x. So hopefully you can see how I've got all of those values into there. I've literally just labeled up the triangle and popped everything into there. Okay. So let's just work these sections out bit by bit. Someone's just asked, how do you tell which rule to use? That's a really good question, and I will definitely come back to that after this. So we just work out all of these. So 32 squared plus 25 squared, definitely not going to attempt that in my head. 32 squared plus 25 squared, 1,649 minus 2 times 32 times 25. 2 times 32 times 25, 1,600 cos x. And then this is just the trickier bit of rearranging. All I'm going to do is add that bit with the cos x onto the other side, because that just means that I'm working with the x on the left-hand side, and that's a lot nicer. Plus 64 equals 1649. So hopefully you can see how I've just added that there. Then I'll subtract 64 from both sides. So 1,600 cos x equals 1,500 85? I'm going to check that. Yeah, 1,585. And then, like I said, I don't bother to actually work out what this is in case it's got horrible recurring decimal or something. So I literally just write that over that, just divided both sides by the 1,600, and then work out the inverse cos of that. So inverse cos of 1,585 over 1,600. And that gives us 7.85. So here our angle X is 7.85 degrees. So a really small angle, which makes sense because these two sides are really long and that one's quite short. So that makes sense that it's quite a small degree there. Okay, a couple of people, now we're at the end. Oh gosh, yeah, math stroke time. Okay, we've got 2 minutes left. So the first thing that I want to do is show you my when to use each rule thing. So I've got it saved somewhere here. I should have had it open beforehand, but here we go. See, I use it so much, it's like in my, at the beginning of my tutoring folder. So I'll show you this tomorrow as well. So first of all, this stuff on the left. So is the triangle right angled? If it is, if it involves any angles, you have to use SOHCAHTOA. And if it doesn't, then it's Pythagoras. So that's the stuff that we'll be covering, I think, in the next couple of days. This is what we're looking at today, a non-right angled triangle. And this is the key question here. Do you know a side and its opposite angle? So do you actually know them? So not is one of them X. Do you actually know a side and its opposite angle? And if you do, then use the sine rule. If not, use the cosine rule. So this is a really good thing to kind of remember. Oh my gosh, be patient. The math stroke is coming, I swear. Now, just because a couple of people have asked, first of all, are there harder versions of this in the exam? These are pretty much the hardest that it will get. A couple of people have asked about one-on-one tuition. I personally do one-on-one tuition. You can find me normally if you put in like maths and computer science, I come up quicker, but you can email my tutor specifically with stuff. But there are also tons and tons of tutors for private tutoring, which I would really recommend. So either speak to my tutor and they can help you, or have a look on the My Tutor website for that. That's something really fantastic that my tutor offers. Okay, so I think we're going to have to finish here. So we'll finish on a maths joke. Are monsters good at maths? Not unless you count Dracula. Incredible. I love that. So thank you very much. Well done, everybody, for doing the quiz and sticking with me today. And I'll see you tomorrow for the next maths ones. Thank you, everybody. Bye.